I hope you all are still tuned in. And yeah, when we had initially asked you right after we all joined for lunch, what are those buzzwords that you often hear? Some of you mentioned immutable infra, and there were also words around scalability as well as disaster recovery. So looking at that, yeah. Tarushi, have you noticed that disaster recovery and go ahead.
Yeah, and also like one buzzword which I think of is chaos engineering.
Yeah, and I'm not surprised why that is so, because a lot of businesses nowadays are investing in having solid architectures that stay resilient even during disaster or unprecedented events.
But like, what are the mechanisms you can use to make the systems robust?
Yeah. Have you heard about chaos engineering, Tarushi?
I have, but I don't have any idea about it, I would say.
Yeah, so basically chaos engineering is a mechanism where you deliberately introduce chaos into your system, chaos or disturbance or turbulence into your system, in order to address loopholes in such a way that it is fault tolerant, robust, and is self-healing. So let's hear more about this topic from Prashanth, who has implemented it in their project. So Prashanth, welcome on board. And for everyone out here, Prashanth is an electronics engineer by academics, software engineer by profession and passion. He began his career with Java backend development and has diversified across multiple technical verticals and domains ranging from finance, brokerage, e-commerce, and banking. Currently working as a tech lead for one of his clients, built platform capabilities for multi-language support at an enterprise scale. He has always been a big fan of site reliability engineering practices and system design. And personally, he loves to travel and cook. Welcome, Prashanth. Over to you.
Hey, thanks, Archana. And Tarushi, let me share my screen. Right. Can you focus on my screen?
Yes.
You see the deck, right? I'm asking because I have two screens.
Yeah. We are seeing the deck.
Cool. So good evening and happy Saturday. I hope this session and the whole in progress is worth your weekend time. So I'll quickly jump into it. I think Archana and Tarushi gave quite a good definition of what it is. I'll try to add some more points on top of that. Right. So chaos engineering, when I say the word, right, the first thing which comes into your mind is we introduce chaos and we try to understand what exactly how good our systems are. So since you already know the definition from Archana and Tarushi, we'll jump into the why. So why do we need this in the first place? So always whenever we always start with why. So I wanted to talk about two scenarios where we have seen production failures. So this is a recent one which I was observing. This happened in January 2023. So Microsoft had an outage on Jan 25 this month. There was a configuration issue which brought down all their Exchange services systems, Teams, Outlook, everything went down for a couple of hours, and it took quite a while to realize what was the issue, and then it recovered. The next example, what I wanted to add was this is a personal example. In one of our, so my current role is we build platform capabilities for a client where we build libraries, right? So we build abstraction libraries on top of Redis to ensure that application teams use those libraries to incorporate connectivity with Redis, and they can use it for the caching purposes. So we built this library, we circulated it amongst multiple teams and everyone. And then when one of the systems went live, what they realized was So Redis is used in Kubernetes. So there occurs regular pod rotation and stuff like that. So what happened was during a pod rotation, the caching system stopped working. So it basically did not refresh the IP of the latest pod which came up. So this was another. This is a personal experience where I observed that an outage was caused because of improper testing, and the configuration was not in place. So these are the these examples might help you understand that why we actually look into chaos testing, where we try to find out places, or we try to find out scenarios where you don't anticipate that you will see a failure, and we try to simulate it even before you go to you roll out to a lot of people. So now I'll jump into what, although we have covered this in detail, I will try to draw an analogy between chaos testing and a vaccine. So I think a vaccine has now become very popular nowadays because of COVID. After COVID, we saw that they started coming up with vaccines, and it's so. What is a vaccine, right? So vaccine is usually like a mild form of a disease itself. So it is injected into the blood so that our body prepares and learns to fight against the actual disease. So failures are also like that, or chaos is also like that. So so you can't prevent a disease. So similarly, you cannot prevent a chaos. They are bound to happen. They will happen, and so the whole uh, idea is to be prepared. So that is what we are going to do here. So we will simulate or inject chaos into our systems, and we'll learn how to fight them. So we'll make our systems immune to them. We'll make our lives easier. So there are so now I'll dive into what are the different types of chaos. So I've taken some popular examples where I'll try to explain why these are all chaoses. So it can occur in many forms, right? Like there is a CPU and memory spike, which is a quite common type of chaos that you see. Like when there is a burst of traffic, you see a spike in the CPU of your virtual machine or your pod or your actual machine, right? So that's a very common kind of chaos. And so is your system prepared for this? So that's the question that you need to be asking yourself. And jumping into the next one, network latency. Network latency is also like, so in the world of microservices, where everybody wants to build a small service with its own responsibilities, right? So in this era, so there is always going to be network traffic bouncing here and there. So what you see is there is if one system goes down, there is going to be a cascading effect on multiple other systems. I personally have faced this when working for an e-commerce client. Like when we tried to we were dependent on a payment system, and that payment aggregator was dependent on PayPal. So when PayPal went down, our whole order system suffered because of this. So this is like this will have a cascading effect. So network latency is something that we need to be very we should pay a good attention to that. And the third one is a very common one, which is application crashes. So pods to come down, applications to crash. So we need to be immune, and we need to be taking this into account while we talk about resiliency of a system. And the last one, which is a very popular form of chaos I've observed recently, is time travel. So when I say time travel, what I mean here is like, so being in India, we have always had like one time zone, and there is no daylight saving kind of thing. But in multiple other continents, they have this concept of daylight saving, where they push the time 1 hour before or 1 hour back, depending on whether it's summer or winter, and that switch is called as daylight saving. So during that switch, when it happens, right? So a lot of systems do not account for that. And again, this also I've personally experienced. I was on call for one of the clients, where I observed that during this switch, if your code does not properly handle things, you would see that there is a 1 hour jump in during summer to winter, and there is this 1 hour gap between winter to summer. So this would actually cause issues when your system is actually working. So all these are just 4 common scenarios that I took to explain the different types of chaos which can occur. There are multiple others, so there are like hundreds of types of chaos, and the list keeps growing. There is no limit to it, but there is a way to try to simulate this. So like nowadays we use multiple vendors, multiple distributed systems, and others. Like for example, there can be like you might use Cassandra, you might use Kafka, you might use your Oracle database, you might use caching systems. So in each of those points, so every new component that you introduce is a potential failure point, or I should say it would introduce multiple potential failure points. So in all of these areas, you can always anticipate that something or the other might go wrong. And again, going back to my earlier point, like there is always going to be, so failure is inevitable. You can be prepared for it though. So that is the thing we are trying to address here. So now let me jump into how. So when I say how, what I mean is like, architectures like microservices and Kubernetes, which they have popularized these concept of disposability and statefulness. So what we have, made our peace with is you design for failure, right? So you always anticipate failure. So network latency and all, you don't take it for granted. So nothing is stable. So you always prepare that things are going to fail, and you try to build a system robust to handle that. And I can talk about a couple of examples already in the distributed systems area, which already covers these. Like I can give you examples like Kafka, Redis. They already have, they have popularized this idea very well by taking in, they have replica systems in place to ensure that they are resilient enough. But just having replica system is not enough. But that is just how how we have grown from a single node, single server system to a more resilient system in the coming days. So I'll take a pause before I go into the how, if there is any questions or.
Okay, I think no questions for now.
Okay, then I'll probably proceed then.
Yeah.
Okay, so I'll jump into the how. So now I'll try to explain the different phases we follow for chaos testing. So typically we do this like I hope we are familiar with this concept of TDD, right? Like test driven development, or what we call as blue green refactoring. So what we do is we first write a test, we make the system fail, and then we try to improve the system to ensure that the system is working as expected. So the phases of chaos testing is also kind of, I can draw a parallel to that analogy, because the first phase would always be like hypothesizing a chaos scenario. So that would mean that I first think about a scenario where a chaos can happen. It can be something like, hey, my pod went down, how would my system react? And then you actually, so you first hypothesize, meaning you would first list down the scenarios, what all can happen. And then you actually do the test where you actually bring it down. If you're talking about bringing the pod down, you actually bring the pod down. Or if you are talking about, bringing the database down and see how your system reacts, then you actually bring the database down. And the third phase is like you analyze the results and you see what exactly happened to the system. Did your system survive? Did you have a fallback? Did you retry? Or did you fail? So this is the third phase. And the last phase, which is what we do, is we make it better, right? So we improve for resiliency. So we understood that, okay, I thought this would happen. I did the test. I saw what happened, what actually happened, and then I improve for resiliency. So I can take an example here, right? So what I would do is like, if I bring down my database, uh, I assume that my system will work properly because I have a cache. And then that is my hypothesizing my chaos scenario. The second step is I actually perform the chaos testing. So here what I do is like, I go ahead and say that, okay, let me actually bring down my database. And then the third step is I say, okay, let me go and analyze. And then the last step would be like, okay, I see that, okay, what happened exactly? And then the last step would be I go and improve my system to ensure that my cache is actually properly configured. The next one is steps that you need to follow. The first step for anything is like defining for the chaos testing is like you define a steady state, right? So this can be drawn parallel to like hypothesizing your chaos scenario, right? So we were talking about bringing the database down for a system, right? So you will say that when my database is down, my web app, for example, hypothetically, should still serve traffic. That can be the scenario. So I define the steady state saying, if my database is down, my endpoints, my web services endpoints are still responsive. So that would be my steady state. So steady state can be different for different systems. So for a web app, it can be like, your homepage is returning success, or for a web service, it can mean that your app is still healthy. Or for for a database, it would mean that the connectivity is still in place. So it can mean different thing for different systems. So you will define your steady state from what it is, right? So you know the best what your steady state is. The next step is actually introducing the chaos. In this case, you would actually introduce the chaos, meaning in our example, which you're talking about, where we will actually bring down a database and see, okay, let's see what happens to the service. So we go and shut down the database, or pull the plug, and whatever we do to actually achieve it, right? So then you introduce the chaos where you bring down the database, or you cause, or if you're trying to simulate another scenario like introduce latency, or bring downtime. So you introduce the actual chaos. The third step is actually verifying the steady state. So after you introduce the chaos, what you do is like you will see if things are working still. So we were talking about the web app, right? So we brought down the database. Is the traffic still being served? So what you would do is like you'll just go and hit the endpoint. You'll see if hey, the endpoint is still up. So great. So the steady state is verified. So if not, then you note it down. Okay, this is a problem that my endpoint is unable to, or my app is unable to serve if the database is down, something of that sort. Last step, a very crucial step, is actually rolling back the chaos to ensure that you, bring the state system to back to its status quo. So you bring it back to its steady state where you say that, okay, so I have done my chaos test. I've verified I've introduced the chaos, I've verified it, and then I bring it back to my original state where I bring the database back up so that things are running. So this is very important if you do a chaos testing in production. If things worked as you anticipated your steady state, however you have defined your steady state, if the steady state is verified, then great, you move on, you run the next test. If not, you fix and repeat. You reiterate the same steps again. And there is a circle in between which talks about monitoring, right? So monitoring is a very, very important piece in all of these. So chaos testing, right? Like it is usually done in production. It is recommended to run in production rather than in local environments. I'll tell you why. The reason is typically, right, people or companies invest a lot in their production systems that they do not invest that much to have their lower environments up to the mark in how they have designed their production systems. So that is the reason why it is recommended to run in production. But it needs to be taken with a grain of salt, right? Like if you're doing this for the first time, you should not do it in production. You should first do it in lower environment, get some hands-on experience on how to, work things out. And you learn the system's weakness. That's the intent. And you slowly, observe and, you know, get a hold of how to do things, and then you go and do things in production. Across all these, monitoring and observability are very, very key, because what would happen is like, regardless of whether you do it in production or not, what is very key here is like you monitor and see what is happening to the system. Like monitoring can come in various flavors, right? So it doesn't mean that you need to, keep monitoring all your metrics and everything. But if you're testing a particular system, you need to monitor all its peripherals and the core system that you're trying to target at. That is very key. So that is very important. Next, I'll jump into the tools which are already available out in the market for kiosk testing. There are both paid as well as open source tools which are available. Netflix is one of the first companies which popularized this idea of chaos testing. So they built a tool and made it open source. This tool is called as Chaos Monkey. This became widely popular, and their system was completely on AWS, on Amazon Web Services. So they run tests in production on AWS daily, every day. Like regularly they run, and they typically, how they started was like they started bringing instances down. They started bringing systems down, and they were trying to observe what exactly was happening to the overall health of the system. So this is how it started. So that was the tool that they built, the Chaos Monkey, but it is very tailor-made for AWS and and Netflix in particular, right? So, but it's still open source. It is still available in GitHub. You can try it out. Another very popular tool was Chaos Toolkit, which is also a very good tool to explore chaos testing. The third one is Gremlin. Gremlin is an open source. Gremlin is a paid tool which offers enterprise support. It's a very good alternative. They offer a plethora of different chaos testing suits you can pick, and they have a dashboard, and it's a very fancy tool. It's very and also very extensive, I would say. Last but not least, which I really want to focus on, is Litmus. This is a very cool tool which we have been piloting. And this is also an open source tool. This is not built by us. It is an open source tool where this treats Litmus treats it treats Kubernetes as a first class citizen, which means that it is built with Kubernetes in mind. And there are quite a bit of systems which are also treating Kubernetes as a first class citizen, and we live on Kubernetes. So we will be using Litmus to do a demo and during this workshop. So since we will be talking about Litmus a lot, I'm going to give you a crash course on what is Litmus. I'll be running through the slides, because too much in depth of Litmus is not necessary to actually run and do a test. So as I mentioned, Litmus is a chaos engineering tool for Kubernetes. It's a cloud native tool. It can be run on the cloud as well as on-prem. As long as Kubernetes is there, Litmus will run effectively. So the way in which it is built is it uses a declarative way, which is nothing but it uses CRDs, like custom resource definitions, for the test itself. So here is the engineering framework for that, right? So it's an open source tool. It provides APIs and CRDs for actually performing the chaos test. And it offers this beautiful plugin infrastructure where it provides a lot of plugins for performing these chaos tests, where you can write your own plugin to introduce a new form of chaos and you can also provide it and to the community for others also to use. So it kind of has this cloud native architecture. We'll talk a little bit of three main CRDs which Litmus provides. One is the chaos experiment, the next one is the chaos engine, and the third one is chaos result. So the chaos experiment is, so I'll first talk about chaos engine. So chaos engine is the one which is actually going to run the test. So that is the CRD which is responsible for actually running the test, where you inject an experiment which is a CRD, the engine actually runs it and it publishes it to a result. And we will check the result to see if the test passed or not. I'll take a pause here because I know I'm providing a lot of information now in terms of like CRDs and Kubernetes and chaos testing. So do we have any questions at this point of time before I jump into how we can use Litmus? And then there is a demo also.
Folks, if you have any question, you can put it in the Q&A section. I think we can proceed for now, Prashanth.
All right. So so I'll jump into each of the CRD and how we actually install these. So first step would be actually to install the chaos operator. There are two ways to install something on Kubernetes. We either use the manifest directly. So here is the Litmus operator manifest. So we can use the kubectl apply command to actually install the chaos operator, or we can use Helm charts. So Litmus provides both. So we created on the Litmus namespace just to have segregation and isolation between the CRDs which are part of Litmus and the one which we have. As I mentioned, we need to set up the chaos experiments as well. So in this case, the experiment here, what we are trying to do is, you install the experiment next, which is here, it is called pod delete. And you can list all the experiments. I'll show all these as a demo also. But basically, the second step would be to set up the chaos experiments in the namespace. The third one is actually injecting the chaos within the namespace. Injecting the chaos. So we first set up the experiment and then you try to actually inject it where you try to simulate the scenario. The fourth step is verifying the result. So in the previous slide, if you have seen, so Litmus creates a CRD for the chaos results itself. So you can analyze the chaos results CRD to see what happened to the test. So currently, the new version of Litmus, you don't need to go too much into the console and the terminal to see how things are working. They have provided a convenient dashboard to observe all of these. So it has become a little bit more user friendly. But we'll be showing in terms of the console so that we understand what is happening behind the scenes. So we also have a steady state hypothesis using probes. What this means is like, if you remember, the first step in chaos testing is like we define a steady state, right? So there is a probe which is available. If you're familiar with Kubernetes, you would know that there is this liveness and readiness probe. It's basically a hook where you provide a for a typical web service or a web app, you would provide your health endpoint to show that your app is up and ready so that Kubernetes knows that the app is healthy. So similarly here also in Litmus also they have a probe in this case, like to check if this is normal or not. And they check that if the endpoint is returning a 200. Again, I will be demonstrating this in the demo as well. So now I will jump into the demo. So here we will be trying to cover an application disruption with pod crashes, right? So before that, I will first see if people have things running and ready if they want to join me with when I'm running a test now in my local. So one of the first prerequisites for this, what you would need is you would need a container based environment, either containerd or Polymer, Docker, anything of that sort. And then along with this, you would also need a Kubernetes cluster. So for Kubernetes, you can use Rancher, K3D, Kind, or K3S. Either of these would work. Or Docker for Kubernetes for Docker also would work. As long as you have a Kubernetes cluster, that's enough for us to do this experiment.
Prashant, do you want the participants to follow along with you on this hands-on, or will you be doing the demo?
Yeah, they can actually. If they have things ready, they can. Like if anybody needs like the exact tool also, I can point out to some URLs.
Yeah, maybe you
Looks
can
like-
post the URLs on chat box and let them install while we can continue. Maybe we can give like a couple of minutes.
Sure. So I will probably post here. So this is. So you can use, I am using Colima for my containerization. So here is the link for Colima. You can also use Docker desktop. That's also totally fine. And nextly, I am using K3D for Kubernetes. You can install this. It's pretty quick way of installation. It's just one wget or curl and you'll be good to go. If you want a more like I was previously using Docker for desktop and then they made it paid for commercial use. So we switched to Colima and K3D. But if you want a more UI similar to Docker desktop, you can use Rancher. I'm pinging that link also. And along with this, I will add so maybe we'll give it some 5 minutes for people to install and get started. In the meantime, I'll probably gather some files. Can I pass in files, Tarushi?
Pass files, Sajan.
In the sense, I have a little set of Kubernetes manifest files which would be necessary.
Maybe you can put it on a GitHub repo and share the repo link here. Would that be good?
Yes, I can do that. I think. Maybe I'll put it in as a gist in GitHub. So this is the application which we will be using. This is a Kubernetes manifest of the app. It's a very, it's actually a part of, it's just a stripped down version of another app which is available as part of Istio. So Istio is a Kubernetes sidecar service mesh. So they have this book info application. So I've just stripped it down to the very bare minimum. If you want, you can install the entire book info app, or if you want to follow this particular workshop, you can. It is enough if you take just this gist which I have provided in the chat. You can go ahead and install this also. I'll show you how to do that. But before that, let me get in all the other resources also. So if people have already downloaded Colima, if you're using Colima, then you can do this. Is my screen visible? Like, is it too small?
Yeah, you can zoom it a little more.
And also, Prashant, most of the people would be Windows. So that we need to.
Okay. All right. I think like still the tools for Colima, I'm not sure, but I think Docker for desktop might still work if it is on a personal machine. Like Docker for desktop, and I think Docker for desktop also has Kubernetes as part of it. So that would also work in a similar fashion. So I'm just going to do my setup in my machine, but other than that, it would be identical. Okay, I'm just going to check my Docker status. So if I do Docker PS, it is up. So my Colima is up. But if you're using Windows, then you can actually start up Docker and enable Kubernetes. So that would allow you to have a little bit of. So if you do kubectl get pods, it should also show you an empty thing if you're not running anything. If you're setting this up for the first time, then you can use all of these tools that I've provided, or I mean, Windows or any other OS, Mac or Linux, it would be almost identical after you set up Docker and Kubernetes. I'm not sure if they have Colima and K3D for Windows or not. Let me check. Okay, they have this Podman probably for, and I think Rancher Desktop has support for both Mac and Windows. So maybe you can use Rancher. So they have this similar Docker desktop kind of an interface. Okay, I hope people have installed at least Docker or Rancher for desktop. And then if we are using Docker for desktop, there is this within preferences, there is this enable Kubernetes. You can go and enable that. That should start a cluster for you. If you're using Mac or Windows, please follow me. So we have this, I'm using K3D. So I'm going to do this K3D cluster list. So I don't have any active cluster at the moment. I'm going to create a cluster. I'm going to create a cluster called TW. And currently there is no Kubernetes is not running and there's nothing which is being written from a kubectl get pods also. So once this cluster is created, you should see. Yeah, so now I have a cluster. So if I go kubectl cluster info, I will see that my control plane is running and is up. So now I get no resources found. So I have a cluster now. I have one server and this is enough just for this demo. Yes, folks, like if you are ready, then I'll go to the next step. I'll install the product page.
Let us know with the reactions. So if we can proceed or not.
I think let's just wait for
Yep.
a minute, and then maybe we can just like you can proceed, Prashanth. Either ways, we will also be having the recording, right?
Yes, absolutely. I'll just give one more minute, and maybe in the meantime, I can just talk about like what exactly is in this product page. I'll just pull that up. So the product page is a very simple, Kubernetes resource. It just has a service account, and a deployment. So this service is exposing a port 9080 and it has a service account and as well as a deployment. So the deployment basically takes this image istio, as I mentioned, the book info app is from the istio site. So it is just one part of it. And post that we have this. We also have also defined request ephemeral storage, and I've just mounted one temp path to it. So what I'm going to do probably before you folks are ready is like just to make it simple, I'm going to import these images into K3D so that I already have these images downloaded in my local. Just putting this into the Kubernetes registry so that it starts with me. I need this, and then as I mentioned, like there are a couple of images that is needed by litmus also to do it. To perform chaos testing, we're going to import the litmus chaos operator into my K3D. And we go run. So these are still prerequisites. This is an optional step. This is just to ensure that the app starts a bit faster. Lastly, the chaos. So what I've done is like I've just imported these images are already there in my local. So I've just imported those images into my Kubernetes cluster so that these are fast. But this, even if you don't do this, it should still download from Istio, so it would still work. Are you folks ready? Shall we get into the next steps? Okay. Let me. First step is I'm going to install the product page app, the YAML file that I showed here. So this will install all these three resources. One is the service account, as well as the deployment. So the deployment, if you see, I've specified this is the image that I want, and this is the image that we actually already imported into kubectl, sorry, K3D. I'm going to do that now. So I'm going to do kubectl apply, and I have this in this repo called chaos conference, and product page. So as soon as I do that, if I do a kubectl get pods, you should see that there is a new pod which is created. And now what I'm going to do is I have this command called watch. So if you remember, one of the key things when we do chaos testing is like you need observability and monitoring. This is a very simple test that I'm going to do by bringing down a pod. I'm going to make the crash the pod. So for that, what I'm going to do is I'm going to do a watch. Watch is like a very nifty tool available in Mac and Linux. So what it does is basically it keeps looping this and putting it on the screen. So if I do watch, what will happen is like this will keep showing, and every 2 seconds it will keep updating what is happening. So that's why we have watch. So the next step after I run the product pages, I'm going to apply my litmus chaos operator. So I've run my chaos operator. So when I do kubectl get pods, if you remember when we talked about litmus, we have this in a separate namespace called litmus. So now when I do a get pods dash and litmus, so this is namespace litmus, you see that the chaos operator is running now. So when the chaos operator is running, this will facilitate all the other CRDs, and it will ensure that things are in place. So now I have a pod which is running, and I have the chaos operator which is running. So now let's go to the next step where we inject an experiment first. We create an experiment first where we will try to install the pod delete experiment. Let me install this. So it says chaos experiment litmus chaos pod delete created. So now let's see that, right? So when I do kubectl get CRDs, so you should see that there is a chaos experiments dot litmus chaos.io. So now I'm going to do a kubectl get chaos experiments. So this is the experiment that we installed now. So you should see that the pod delete experiment is available, and it was created 25 seconds ago. So we will be using this experiment to inject chaos into our product page app. All right. So now for the experiment to work, there is also a service account which is necessary to ensure that it has enough permissions to actually bring down the pod. So now let's install the service account. So there is an RBAC which is there. So it just creates the service account for the pod delete CRD. Lastly, we can actually start the experiment, or we activate the experiment. So the experiment is already available, and then we have the service account. So the service account is kind of optional. This is like when you do things in production, because what would happen is that the app, the pod which litmus spins up should have access to the cluster to ensure that it facilitates all different forms of chaos. So to facilitate that, we have this RBAC created or the permissions. And so this account would give it permissions for it. Now let's go and activate this experiment. So what I'm going to do is, so I'll first walk you through what exactly happens within this pod delete.yaml. So here, if you see, the pod delete is a kind of chaos engine. So the chaos engine is actually the one which runs the experiment. So this is the last one which you'll use to actually start the experiment. So it is of kind chaos engine. I've just given it a name, product page chaos. And I've said that the app label is app equal to product page. The reason why we do this is like, this is what specifies that, okay, the chaos engine called product page chaos will target a pod which has the label as product page. So if I go to product page, you will see that there is a label called app product page. So to ensure that this pod, the pod delete experiment targets the product page, so we have to add a label to our deployment, and this label must be provided here, the app label. And we're also saying that the app kind is a deployment. So it will target the deployment object of product page. The next one is the engine state, which is active. And then there is we have provided the service account name. And here is the experiment start. There are multiple variables which can be used, which you can explore as part of the Litmus website. I'll try to explain quickly what each of these mean. So there is an environment variable called total chaos duration. So this experiment runs for 30 seconds. So we specify that the total chaos duration is 30 seconds, and chaos interval is provided in seconds. So the chaos interval meaning like at what intervals will it rerun the chaos if the so there can be multiple, it will keep doing it until the experiment total chaos duration stops. So between two different chaoses, there is an interval which is specified. So that is this chaos interval. And the next one is force. Force proof meaning in Kubernetes, we have this termination grace period to ensure that our pod has enough time to gracefully shut down. If you don't want to respect that, you can specify that the force is true, which means that it would force kill the pod. So it would mean that it would just, the controller, the pod will send a sig kill instead of a sig term command. So it will directly try to eliminate the pod. And the last one is we have this pod's affect percentage. Like in this case, like if you want to target only like, if you're running it in production, if you want to target not all pods, but just, like 10 to 20% of the pods to see how your entire system is reacting. So you can specify a percentage here. But in this case, I don't want to do that because it is not production for me. It's just an experiment. So I just left it as empty. So it would target 100% of the pods. And in our case, there is only one pod here, which is in running state. So it will affect that pod. Next one, we talked about probe when we were running through the Litmus chaos overview. So the probe is nothing but it is like it will tell you what exactly to check to verify the steady state. In this case, like we are going to use a HTTP probe, and the HTTP probe URL is HTTP product page :9080. So this is like the service URL for the product page. So if I go here, you will see that the service name is product page and the port number is exposed as 9080. So here we give the same, and insecure skip verify because this is an HTTP call. We use this, and what we are expecting is the get for this URL response with a 200. So the criteria is equal to, so we say that if this experiment is supposed to succeed, then you should get a 200 from this probe. And the probe should run continuously, and we have some more specific probe specific properties like probe timeout and interval. How frequent should this probe run, and it should retry once. One retry is allowed. So this is like controlling how much failure is tolerable for your experiment. So if 2 seconds is fine, like if you're okay to wait 2 seconds, then it's still, you consider your experiment to be a success, then you would specify that, okay, this is okay. So that is why I specified the polling interval as 2. 1 second, I will just get my charger. Yeah. Right. So the probe is used to ensure the steady state is in place. So now I will actually install the experiment and let's observe what happens. So this is our monitoring tool. And now let me install the experiment. So I apply and let's watch here what happens. So if you see here, immediately the chaos runner starts and there is a pod delete container which is also starting. It is also in running state now, and observe the product page which is in running state now for the last 9 minutes and 31 seconds. Let's see what this pod delete does. I'm going to copy this and keep. Yeah. So if you observe what happened was the pod got destroyed by the pod delete and the chaos runner. And if you see, there is a new container creating and then it crashed it again because there was a 10-second interval. And now the age is 6 seconds because this is a new pod which is being spun up by Kubernetes. So if you remember, what Kubernetes does is like, so it just killed it again. So the chaos experiment is keeping on running as long as the total chaos duration is not complete. So observe this particular window, like this particular part of the window where the pod delete is running and it keeps killing the product page. So it has killed it multiple times already. And now it is in complete state. So if you observe the status is completed, what this means is the experiment is complete. So now we can analyze the results. So I will reiterate. So the steps for chaos testing is we first define the steady state. Here we say that what we want is this page to return a 200 at an interval of probably 2 to 5 seconds. And as long as this condition is satisfied, which means my experiment is success. If not, my experiment is not. And what we are trying to do is we are trying to delete the pod in a duration of 30 seconds with a 10-second interval, and we are forcing it to get killed. And we are targeting product page app. So with these parameters in place, we ran the experiment and now the experiment is complete. Both the pod delete and product page chaos runner is in completed state. And we see that product page is still running. Great. So we survived. So now let us look into the chaos results. Sorry. So I'm going to do a get of chaos results because my experiment is complete. No, I want to see the results. I'm going to do this get. So this got created 2 minutes ago. I'm going to do a describe now. I'm going to do a describe this. Yeah, I'll just maximize this so that we can read. So in the result, if you see what we are trying to do is we have done an experiment of pod delete and the result is awaited initially in 2 minutes 44 seconds, and then at 103 seconds we see that the result is pass. The result is pass. Why? Because we gave the status as continuous probe and the HTTP probe with the particular parameters in place, the interval, the HTTP probe passed. But we did kill the pod, right? So can someone tell me why this experiment passed, although we did kill the pod? Somebody wants to take a guess. I can see that folks are maybe deep and drowsy after lunch. Anyway, I'll jump into like why this actually survived. If you look at the manifest, right? So the product page manifest, I've jumped into the manifest again, and there is a difference between a pod and a deployment. So in Kubernetes, the deployment usually ensures that you always have high availability. And in this case, we have set the replicas to be 1, which means that the Kubernetes controller always is aware. Yes, Abhinav, you're right. So Kubernetes respawn the pod. So that is why we see that the status is pass. So the replicas is set to 1. So the Kubernetes controller always ensures that there is at least 1 pod which is available off product page, always in the cluster. So every time the pod came down, it kept spawning back up, which ensured that this, this experiment was a success. Let's see if we find something interesting in the pod also. I'm going to describe the pod. Okay, but probably it spinned up a new pod since I deleted the pod. Yeah, but anyway, so I'll just go again into the kiosk results. So that is the reason why you see that the verdict is success and the probe success percentage is also 100, because the health probe always returned 200 quickly since the pod came back very fast. That concludes our experiment for the demo. Any questions before I go into the slide back? Yes, Abhinav. It was a very lightweight pod, so it did not take much time to start also. Like the nature of for the demo, we thought it will be quick to do it. So it is, if you have a bit more heavyweight pod which starts up a couple of systems and a couple of services, then it connects to database and stuff like that, then it would have taken a little bit of time. But since it's a very simple pod, it started up very quickly. And it came to the running state also very fast. So that's why the probe never failed. Like even the interval where it went down, we had this probe interval of around 1 second. The probe timeout and the probe interval was like 2 seconds. So that was enough for Kubernetes to bring the pod back up. That concludes our demo. And I hope you folks are able to follow with me on at least a part of the demo. I hope so. But nevertheless, I think and let me do one thing. I'll also post the spot delete also as a gist, and I'll post it to the group so that you can also try it out. So I have this readme. I'm going to post this also if you are interested. So this was we'll post this in the Zoom chat so that you can run it on your local machines as well. Yeah, I'll jump back to the slide. So if there is no more questions, the next So see, we covered quite a bit of material, like where we started with why we need it, and then we jumped into what is chaos testing, and also how. Okay, I see that. Oh, I did not send this to the entire group, is it? Sorry, my bad. I did this now again. Thanks, Mahindra, for pointing that out. And let me send the pod delete gist also again, as well as the gist for product page. This is just a stripped down version of Istios one, but it is still helpful. I hope other resources are available. I used K3D, you can use. You can also use Rancher for Kubernetes. And I have used Colima for containerization. Yeah. Hey, sorry about that, but thanks for letting me know. Mrityujna. So Mrityujna is saying that she's unable to copy. Copy what? Sorry, Mrityujna.
I think people are not able to copy the contents from the Zoom chat. It's there for me as well.
Okay, let me do one thing, right? So probably I will put this as a file. Would a file work, or read me on GitHub?
Just or yeah.
But the gist, are you able to copy, or gist also we are not able to copy?
The links should work, I guess.
The links will open up, yeah, but any other text that we are not able to copy.
Okay. All right. Let me just put this read me into also a gist and then paste it. I think that is the only way. Just- Okay. Now is it okay? I think others are all links. Only this the readme I've just pushed it into a gist and I've provided that as markup. Okay, cool. So I'll jump back into the content. We are in the penultimate slide where we talk about the key benefits of chaos testing. So the first benefit, as you might already be aware, is like we increase availability. So availability and resiliency are one of the key pillars which we try to address as part of chaos engineering. What we have observed is like more than 99.99% availability has increased when teams run chaos experiments. So they're able to plan for their failures and mitigate and uh, mitigate this. And like I personally have been on call, so I'm aware of how stressful it is when you don't know what you need to do when you see failures in production. So it's always better to run a test, be prepared. It's like more of a fire drill kind of thing, right? So it's a mock thing where you run it once and see how things are, and then based on that you you already have a playbook on what you need to do. You need to do step 1, step 2, step 3. So chaos testing does help you achieve that. So that is the second key benefit, which is reduced MTTR. MTTR meaning here is mean time to recovery. So from Gremlin, which is one of the industry leaders in chaos testing tools, they have published a report where they've said that they have conducted a survey where they have said that around 23% of had after they did a chaos test on their production systems, they observed that their mean time to recovery has reduced to under 1 hour, and 60% of them has reduced to under 12 hours. So this is still a pretty big deal, like for systems at internet scale. Like for example, even the first example which we talked about with Microsoft took at least 2 or 3 hours for them to identify what the issue was. So this is still a groundbreaking feat. So there are these are like major key benefits out of chaos testing. It does require quite a bit of setup and buy-in from the stakeholders that you work with, but it's definitely worth it because we have done it, and they have the business stakeholders that we've worked with have been very appreciative of the fact that we actually anticipate failures and we prepare for it. So do try it out. So this is my last slide. So thank you for taking your weekend to listen to me, and I hope I've added some value, and hope that I have kindled your interest in chaos testing and chaos engineering. Hopefully, I see some of your systems also onboard into one of these tools. So there are open source, as I mentioned, there are open source tools which are also available for free. So do pitch chaos testing for your systems to your stakeholders and see if this helps you in terms of overall system resilience. And now I can take any other final questions that you might have. So here's my LinkedIn profile. If you want, feel free to connect. If you're very interested in SRE kind of things, I'm happy to chat.
Christian, regarding TerraFile workshop, the resources, so these recordings will be put up on YouTube later and links will be shared. So yeah, that should be accessible for you. Any other thing you were referring to? Any questions for Prashanth?
I just hope I didn't put everybody to sleep.
No. I think everybody was, in fact, like some of them were doing hands-on as well, I suppose.
Right.
Cool. All right. That was great. Thank you so much, Prashanth. And here we are in the track to the workshop series. We come to an end here. Just before we move away, any key takeaways from the participants? 2 key takeaways, you can put it on chat. What is it that you have learned? What is it that you're going to go back and explore from today's afternoon sessions, TerraFile and chaos engineering? Anyone?
Okay, and there is this Google form for feedback. So we would really appreciate if you all could fill that. I hope everyone has received the link. Please do fill this form and let us know, and so that we can collect the feedback.
Yeah, and while you do that, this is not the end. We have our track 1 series continuing. The talks are happening in the track 1. There's a different Zoom ID for that. We will share the link over here, and there are 2 talks that are one currently happening and one yet to happen. Building scalable MQTT infrastructure for multi-tenant IoT platform. And we also have at 5 o'clock error handling in distributed systems by Deepthi Mittal. So these are again very interesting talks, and we would love for you to join those. And do join for the closing note. We have our infra evangelist, Keith Morris, joining us for the closing note. So we would love to see you there. And I'm posting the Zoom link over here. So you could join the other track for the talks currently happening.
Yeah, thanks, folks, for being a great audience. Thanks, Archana. Thanks, Shane. See yourself for support.
Thank you, Prashanth. Thank you, Shreyarsha.
Yeah,
Thanks,
and thank you, everyone. See you all. Bye-bye.
Bye.